Good afternoon. I'm Beth Long. I am a software engineer on New Relic's reliability engineering team.
And I'm Matthew Flaming. I anchor the site operations group at New Relic. And it's really a pleasure to be here today, in particular because today we get to talk about a subject that I think both Beth and I are really passionate about, which is how DevOps and reliability processes can come together to create a really empowered, innovative culture of shipping great software.
So we're going to tell a story today about learning and growth. And that story begins in 2014 with a Sev 1, a Severity 1 incident, which is our most serious categorization of service disruption. And it ends a little over a year later in 2016 with another Sev 1. Now, you might say that doesn't seem like progress, going from one Sev 1 to another. Well, in one sense, yeah, we have not figured out how to beat Murphy's Law.
Yeah, right?
Yet. But let's dig into some of the details.
So this is a slightly family-friendly-ified version of an actual follow-up email to that incident in October of 2014. And it looked this way not because a service disruption happened, which is regrettable, but you know, it's life. It looked this way because of the way it was handled. We didn't communicate well internally. We didn't drive the incident to closure as quickly as we could have, and maybe most importantly, we weren't as transparent as we wanted to be with our customers. And you know, in the clarity of hindsight, what had happened was our scale had really outstripped our processes for dealing with this type of thing. And because of that, our organizational reaction was one that was coming from a place of mistrust and anxiety.
So in 2016, here's what the communication looked like around that other Sev 1. A lot more boring, which is a good thing for us. So this time we had a plan in place. We were being transparent both internally and with our customers. And we knew that even if shit was on fire right at the moment, that we had the right tools and teams in place to deal with it.
So a minute ago I mentioned scale. And before we dive into the nitty-gritty, I think it's important to spend a little bit of time on that because that context matters. So when we talk about scale in general, and at New Relic, there are really two facets to this. First of all, there's scale in the traditional sense of number of requests handled, overall workload, bytes processed, and these numbers represent the workload that the New Relic platform is handling every minute of every hour of every day, 365 days a year. But behind these numbers, there's actually another set of numbers which are equally important, and that's scale in the sense of complexity. So at this point, the New Relic platform is a pretty sophisticated piece of machinery. We have over 200 unique services. We have petabytes of SSD storage alone. We have over 40 teams who are doing dozens of releases a week. So again, this context is important because it's a fundamentally different problem to coordinate 10 engineers and to coordinate 200 engineers. And when we talk about our reliability processes, it's important to keep in mind they were designed to really support this kind of scale, both in the sense of being a pretty serious data platform, but also working in an environment where change is happening pretty fast. So let's actually peel back the covers just a little bit further and look at how New Relic engineering is built. So at New Relic, we function in small, full ownership teams. Teams are typically 4 to 8 software engineers and site reliability engineers, or SREs, who are first-class members of the teams they work with. So what does full ownership mean in this case? It means that teams really are empowered to build, manage, and operate their own portfolio of services. So teams do their own deploys, they create their own runbooks, they do their on-call rotations, and manage their own processes. And there are a couple of reasons why we set up our engineering organization this way. The first is we really want to make sure that all of us have skin in the game and empathy for what we're delivering to our customers. You know, if your bad code is waking someone else up at 2 a.m., it's hard to really feel that urgency around fixing it or how it's impacting people. So that's the first reason. The second reason is we want to make sure that our teams can move fast, can innovate, can ship great software, and they're not bottlenecked by anything else. So if we had a centralized operations group or a centralized NOC, it would create that bottleneck that slows us down organizationally and also, in a way, disempowers our teams and takes them away from the end result of what they're delivering.
So that takes us back to 2014, to that awful Sev 1. And looking back, one thing did go right. We did fix the issue.
Eventually.
eventually. What went wrong was pretty much everything else. So it took us 6 hours to correctly identify a root cause after a couple of false diagnoses. It took an additional 2 hours to actually implement the fix to that issue. During that entire time, we were reflecting the outage on our status page, but we were not proactively communicating to our customers. Even within New Relic, a lot of senior staff didn't know what was going on, hence the irate email that you saw a little earlier. So we did get the job done, but the whole process was confusing, frustrating, and opaque. If we step back, this is what some of the evolving practices over the subsequent time frame looked like. And you can see there's a lot of change going on here, and we're going to get into some of the details here about how that evolution took place. Now, I keep using this word evolution, and that is deliberate. It's to underscore the fact that this process was not one of linear development. We had a lot of false starts, a lot of wrong turns along the way. Formally, you could describe the basic unit of that process as an OODA loop, right? The observe, orient, decide, act cycle that most of you are familiar with.
It's true, but when you're actually living through it, it feels a little bit different. It feels much more like, there's chaos and then paralysis while everyone's afraid, and then eventually adaptation. This is messy stuff down in the trenches.
It really is messy. So let's dig into the messiness and talk about how things took shape. So immediately after that 2014 incident, we knew that we had to change how we were doing things. We had to avoid having another incident of this magnitude, whatever that took. We needed to have a better way of calling in support throughout the organization when we did have an incident and communicating both internally and externally. And we needed to do a better job of tracking incidents. So we rolled out a few new systems within about a month. The day after that event, we implemented the big red button. This was just an email distribution list that blasted out to the senior technical staff and executives if there was a problem. Then we instituted a change acceptance board, which was a manual process. We heard about this a little bit earlier. Manual process of scrutinizing and evaluating releases before they went into production. And we were doing retrospectives at the time. They were blameless, but they were also disorganized, and a lot of what came out of them was scattered. So we built an internal incident management tool called Upboard and rolled that out within about a month. So the first lesson here is simple. It is, don't wait for perfect answers. If duct tape is what you have, go ahead and start with duct tape and then iterate based on that.
Absolutely. Okay, so we got our duct tape operationalized and up and running. Now what comes next? So it's useful to look at the example of our change acceptance board, the CAB, which we introduced at this point in time. And in its first incarnation, what this looked like was actually going into a dimly lit room with a couple of architects and trying to convince them that your changes were safe to release. And this did in fact help us catch some risky releases, some potentially conflicting deploys, and maybe most importantly, it helped teams slow down and think more conscientiously about the risk their changes might introduce. So all of that's good, but as you might imagine, not exactly popular with engineers. And we also found pretty quickly that over time, our releases were getting bigger and bigger as changes piled up behind the cab. So in fact, ironically, we had increased risk through the law of unintended consequences. So we said, okay, well, what if we try an experiment? What if we try and make the cab partially self-serve? So we built a tool around a calendaring system that would let engineers see other scheduled releases and submit a request for their own release slot along with an evaluation of risk. Low risk, auto approval. High risk gets sent to the architects for review. So again, this is progress, but we realized we still weren't solving just the core problem. What we were worried about wasn't really code quality issues. What we were worried about were people not being aware of the context in which their release was occurring or taking appropriate mitigation steps. So we went one step further and developed a tool that we call Gatekeeper. Gatekeeper is essentially a pre-flight checker for releases. It makes sure that a release's dependencies are healthy, that preconditions are met, and if something is wrong, generates warnings and also creates visibility around other releases. So now teams can just include Gatekeeper in their deploy pipeline And they can make autonomous decisions. They can be smart on their own about whether it's safe to release, whether they want to hold off. They have visibility into the whole system and how their change is going to impact it. So the lesson here for us is it's so important to just keep focusing in on the core problem you're trying to solve and strip out everything around that that could be generating friction or frustration or disempowering people to move quickly.
So going back to that big red button, the email distribution list, it was a sledgehammer. It gave us visibility into what was happening at the time, but it also meant that there was no alternative between an engineer going it alone and calling in the infantry. So engineers were actually avoiding calling for help because calling for help was such a big deal. In fact, at one point someone asked, is there a smaller big red button? So we made smaller buttons. We created severity definitions, which allowed us to differentiate between we're experiencing some lag and the entire site is down. We created 5 categorizations and over time tweaked those definitions as we figured out what made the most sense for us. We also evolved the big red button itself from an email distribution list to having executives and senior staff actually go on call alongside the engineers. And so between improving our on-call rotations and having those severity definitions, we were able to start to be more selective about how and when we sounded the alarm. So that reduced pager fatigue across the board. And we also created a new team, the new Relic Emergency Response Force, or NERFs. So these are our most battle-hardened incident commanders. They have the experience and the personality to step in during a crisis and call the shots. So they get paged automatically on high severity or long running incidents, and they know how to make sure that things run smoothly. They're also critical when we have an incident that we're not prepared for because they have so much experience that they can improvise. So the lesson here is reducing your mean time to resolution is mostly about your process and your people. You need to start with making sure that you have processes in place so that incidents become manageable, even routine. But you also need to make sure that you have the right people in place for when things go sideways and your run books can't keep up.
So in the wake of the October 2014 incident, we knew we needed to work on our reliability and improve it like a lot. And we're a pretty ambitious organization, so we started out by setting a pretty ambitious goal, which is 100% uptime. Now, sounds good on paper, right? But if you've ever actually worked with software, you realize this is a pretty high bar. And as we pushed towards it, we started to hit the law of diminishing returns. You know, it's kind of hard to get to 99.99. Turns out it's a lot harder to get to 99.999. And as we pushed in that direction, we realized that we were diverting resources away from building features that our customers were requesting, and that we might be over-investing in reliability. In other words, we figured out that reliability isn't an all or nothing game. Instead, it's really a matter of trying to understand what success looks like and then investing appropriately to make that success happen the same way that you'd invest in a feature, because it turns out reliability is a feature. So we moved away from 100% uptime, and instead we started to think about building models that captured how reliability issues impacted our customers. We wanted to focus on the things that really impacted our customers most, to build models that prioritize things that really hurt our customers and lent less weight to minor features being down, for example. So we started out with a model called CrapDex. That wasn't quite right. We've evolved that into something we now called QuasDex. We've tweaked that a little bit over time and feel like it's now a pretty accurate representation. And we're now supplementing that top-down view with programmatic per-service SLIs, service level indicators. So we have very precise targeting information on where to do our reliability work. So the key takeaway here, I think, is that the question, is our reliability good enough, is actually a crap question, because both reliability and good enough mean really different things to different people. And the key here is to move that conversation out of the realm of impressions and opinion and to find an empirical way of talking about your goals and measuring your success towards those goals.
So all of these things have improved our mean time to resolution, but we also needed to stop recycling the same issues over and over again. So we began doing that by implementing an availability learning review process. This was, again, a manual process frankly, a painful one, where after incidents, engineers would come before a board of senior executives and technical staff and essentially confess their sins. So the purpose was to learn and to hold ourselves accountable. But as you can imagine, the more common side effect was to demoralize teams and actually discourage transparency. So we threw that out. And we shifted our focus from who to what. What exactly had gone wrong? What did we need to do right then and there to fix whatever had come up in an incident? And this is what led to DRI, don't repeat incidents. So now, one of the key things to come out of a retrospective is identifying which tasks qualify as DRI tasks. If a team has DRI tasks from an incident, they drop everything they're working on, and they focus on that, resolve it, and then move on. Now, in retrospect, this process of don't repeat incidents seems incredibly obvious, but I'm sure most of you know that the momentum of the engineering machine is such that it is really easy for follow-up actions to get lost in a pile of conflicting priorities. So the DRI process that we instituted really was the key that unlocked a new era of stability for us at New Relic. So the lesson here is that it is not enough to get the right answer for one incident. You have to make the right answer easy every single time, and if you make it easy enough every time, it will become inevitable. Now, at the same time, we discovered that a lot of our engineers were having a difficult time deciding what to work on in terms of reliability. They could see so many opportunities for improvement that they were being paralyzed by indecision. So to help think about this, we instituted a service maturity model, which we called Visine, so people could see more clearly what they needed to do. And it consisted of 3 tiers. The first tier was identifying known risks. This is where risk matrices come in. So we asked each team to think of all the things that could go wrong with their service, put that into a matrix, and assign each issue a likelihood and a severity. So this allowed us to prioritize the reliability work, because obviously, more important to work on a high likelihood incident that would have a high impact than a low likelihood incident that wouldn't have much of an impact. So as long as teams kept up to date with their risk matrices, we could be confident that reliability efforts were going to the right place. Now, risk matrices are interesting, but of course they don't actually solve the problems in and of themselves. So the next step is to make sure that if those things happen, we know about it. That's where monitoring and alerting come in. So we ask teams to ensure that they were monitoring and alerting on those issues, once again using the risk matrix to set the priority, starting with high, high, and working our way down from there. And finally, we were able to get proactive. So we asked teams to fix or mitigate the issues on their risk matrices. And in practice, this looks like usually taking issues that are in that high, high corner and just moving them as far as possible down to the low, low corner of the scale. Then we asked teams to do regular game days. So game days are where you're deliberately injecting faults into your systems on production. And if you remember the scale at which New Relic operates, when you're at this level of scale, traditional testing is necessary, but it's not sufficient. And it's insufficient because at this level of complexity, it is impossible to predict everything that could go wrong in production. So with game days, not only are we validating that risk mitigation was successful, but we're also able to uncover new and unpredictable faults before they surprise us in production in a reasonably controlled experiment. So the lesson here is not to wait for incidents to show you what your problems are. Start by identifying, monitoring, and mitigating the issues that you already know are there, and then poke and prod at your system to figure out what is going to surprise you before it hits you in production.
So this is an example of a risk matrix. Each team at New Relic has at least one of these. And again, we found this to be an incredibly useful lens through which to look at where we most need monitoring, where we most need alerting, and where to focus our reliability work. Now, an actual risk matrix would be a little bit more extended than that. Typically, it would also have a mitigation plan and then a remediation plan as well, but this is really the core of it. So what does this look like in practice? Well, I think a really useful example is looking at how we monitor and operate NRDB. So NRDB is our proprietary database that powers many of New Relic's features. Earlier we talked about event data. NRDB is what powers event data. And there are three main tiers of nodes in NRDB that are responsible for ingesting, storing, and querying data respectively. But to give you a sense of the scale of this thing, in any given one of these tiers, at a given time, there will be hundreds of hosts and thousands of processes running. And these different tiers communicate via HTTP, via PubSub, via streaming. And they're supported by a set of ancillary services that are themselves distributed systems. For another perspective on scale, at any given time, NRDB is writing about 300 million new data points a minute and processing about 300 billion data points a minute to service customer queries. OK, so how do we keep this beast running and happy? Well, there are actually a set of tools that we use. So, of course, we use APM for code-level visibility on all the nodes in the system for pinpoint troubleshooting. But in a distributed system like this, you can't really look at health from the perspective of a single node. Health actually is an emergent effect that comes from a lot of different node types working together. So this is where we use insights to get cluster-wide visibility into those emergent behaviors. And we use synthetics for die marker testing. So we can use synthetic transactions to insert a piece of data in one end of the system and make sure we can query it out the other end of the system the way that we expect. Now, we use APM alerting and also some plugin alerting throughout NRDB. But at this scale, even a very, very low overall error rate could mean millions of dropped data points. So earlier, Susie spoke about Norc Alerts and gave a great dive into that. We use Norc Alerts here to alert on leading indicators of problems ahead, like fluctuations in latency on very sensitive queries that allow us to get ahead of those problems before customers notice them. Finally, we found that looking at the actual hosts in these clusters is very important as well for maintaining reliability. You know, these hosts, they're not pets, they're cattle, but we still need to keep our herd organized and consistent. We found that inconsistent configurations or unexpected config changes are key sources of risk. And this is where our infrastructure product comes in to give us insight into those types of conditions. So really the lesson here is that there's not a single silver bullet tool that solves all the problems that come up in a risk matrix. Instead, it's a set of different tools working together and reinforcing each other that let us keep NRDB operational and healthy, even at massive scale. So there's one more, I think, reliability lesson that's worth touching on, and that has to do with our organizational structure. Back at the beginning of this, I mentioned that at New Relic, we work in teams where software engineers and SREs are both first-class members, but that wasn't always the case. Back in 2014, we did have SREs at New Relic, but they mostly lived in a couple of centralized teams in site engineering. And the problem there was our SREs weren't engaging proactively with teams around reliability issues. Instead, teams had to come to them and then, honestly, have to wait in line quite often to get their needs met. So this led us to our first evolution, which was moving to the model of forward SREs. So in that model, an SRE would work with a given team for a period of typically a few months to help that team with their tooling, their processes, and then rotate on to another team. So this is an improvement, but the problem here is that when that SRE moved on, the team might be left with process and tooling they didn't fully understand and wouldn't necessarily be ready to tackle the next challenge that came up with them. So this led us to iterate the organization again to where we are today, embedded SREs. So now SREs are first-class members of their teams. They don't rotate between teams. And there are a lot of benefits to this. There's long-term alignment and skin in the game for the work that the SREs do. They have an opportunity to become domain experts in the software that team is building and operating. And they have an opportunity to mentor other members of the team and help them grow the SRE skill set. So we're growing our collection of SREs all the time. So this is great for empowering teams to do good work. But there are some organizational issues that it doesn't address. And this is why we implemented two new pieces of our structure, the reliability engineering team and our site reliability champions. So although each team and each management chain is responsible for the reliability of their own services, giving those teams actionable data and well-curated best practices around reliability makes them enormously more effective. And that's the mandate of the reliability engineering team: actionable metrics, tools, and best practices around reliability. There's also a category of reliability issue that goes beyond the scope of a single team. And this is where the site reliability champions come in. The SRCs are technically senior staff with a mandate to work with a group of teams to surface, prioritize, and remediate reliability issues that are cross-cutting and go beyond single team boundaries. So really the key takeaway here for us is that, although we really value the autonomy and innovation of our teams, autonomy doesn't mean going it alone. In fact, reliability does really need organizational investment in infrastructure in order for teams to thrive.
So earlier we heard about the importance of experimentation and failure, and this chart bears that out. We had some notable failures along the way and a lot of processes that had to evolve in response to the changing pressures. So we have pulled back the curtain on some of our missteps. Let's brag a little bit.
Let's brag a little.
Yeah. So this is a summary of our current reliability practices. And the core of those practices consists of our service maturity model that lays out the basic principles of identifying, monitoring, and mitigating risks. And our reliability engineering team, which owns the processes and tools for the entire organization and evangelizes reliability. On the mean time to recovery side, we have incident management tools such as Upboard, which allows us to track incidents, and NerdBot, which is a chat bot that our incident commanders use to help incidents run more smoothly as they're happening. And then we have our NERFs, our emergency response force that is on hand to make sure that the worst incidents run smoothly. In the meantime, we're working on reducing our mean time between failures. So we run regular game days to validate our risk mitigation and to uncover new problems before they can surprise us. We have our site reliability engineers who are down on the ground in the teams themselves, working on improving day-to-day reliability for their services. And then the site reliability champions who are up a level looking at reliability issues that cross team boundaries. And the ground that all of this is built on is autonomous, full ownership teams, where we give them both the responsibility and the power to own the reliability for each of their services. So the change that we saw earlier, all those shifts, wrong turns, that's a sign of health. That's an indication that as technologies and organizations are changing so rapidly around us, that our thinking is evolving to keep pace.
So if there's one kind of action item I'd like to suggest out of this is, if you haven't experimented with something like a risk matrix, it's an incredibly useful tool. You may want to take a look. Lee Atchison, who will be talking after the break, actually writes about this in his book, and you can pick up a free copy at his signing, so I would encourage all of you to do that. But backing up a step, we talked earlier about DRI, or Don't Repeat Incidents policy. And in a way, that kind of summarizes our organizational philosophy in a nutshell. Being able to make experiments and understand that sometimes those experiments will fail and learn from those mistakes is much more important than trying to look for forever right answers, which might not exist anyway. In the same way that the process of evolution isn't linear and never ends, so too is the process of discovery. And at New Relic, we're building tools and systems based on the lessons we've learned, operating these complex, high-scale platforms, and based on what we've heard from our customers and from all of you. That doesn't mean we have all of the answers, but we are incredibly excited to share what we've learned, to continue the conversation, and to continue this journey together. So thank you all very much.